Hi, today we will discuss class 11th physics banking of roads on circular track. So at a turning you can see inner side is lower, outer side is somewhat height. What is the reason? So you can understand why they are arranging like that. Banking of roads. At circle turning you can see here turning like this, and this is the radius of this circle. This turning means it is a part of a circle, so it has some radius. That radius is r Ivasum. This is inner edge and outer edge. This is theta angle with the horizontal. Here you can see the car on the road. So while getting turning, three cases is there. Three possibilities. One is safe turning, and you can see in the safe turning here centripetal force is outward force is mv square by r, and weight of the car is mg is acting downward, and normal is act normal to this inclined surface. And normal I am going to resolve into two components. This is theta, this is n cos theta, and this is n sin theta. N is I am resolving into two components. Here three possibilities is there. One is safe turn. In safe turn, n sin theta must be equal to mv square by r. That means here n sin theta is providing sufficient centripetal force. Then only it can move safe turn. And second case, there is a possibility to slide downward when n sin theta is greater than the mv square by r. Slide down inwards when n sin theta is greater than mv square by r in this case. And if outward force is greater than the inward force, then it skid outwards. Skid outwards. N sin theta is less than mv square by r. In this case, what is the maximum velocity? While getting this turning, what is the maximum velocity? So you can observe at circular track, speed limit 60 km per hour, like that you can see. Why they are arranging like this means based on the banking angle. That means theta value. Now we will see three cases one by one. I am extending for flat surface up to dotted line. This is the radius, and this is the inner edge of circular turn. This flat surface I am inclining theta angle and raising the outer edge theta angle with this is outer edge. Now what is meant by banking of roads? Here rising of outer edge than the inner edge is called banking of roads. That means outer edge you have to rise comparing to the inner edge. The rising of outer edge than the inner edge is called banking of roads. Here theta is called banking angle. Here how much angle theta to be raised to get the vehicle safe turn in circular track, that angle is called it as banking angle. Theta why we are rising here to get the vehicles for safe turn. Now what are the forces acting on the vehicle? Here on the vehicle weight is acting downward. Mass of the vehicle is m. Weight is mg. And centripetal force outward force mv square by r. and normal reaction, normal to the inclined plane. Now normal I am going to resolve into two components. One is horizontal component, another one is vertical component. Now this is theta, and this is 90 minus theta, this is theta. So this is theta. This is theta, this is theta, this is 90 minus theta, and this is theta. This is a free body diagram for car on a circular track. Weight is acting downward, mg. Now the car is moving with velocity v. This is horizontal component n cos theta for normal reaction. The vertical component is n sin theta. I am dropping this n because already I resolved into two components. One is n sin theta and another one is n cos theta. Again simplifying this diagram, this is car and weight is acting mg and centripetal force is mv square by r, and inward force is n sin theta and upward force is n cos theta. Now first point, n sin theta, which is equals to, for getting circular turn, safe turn, n sin theta, which is equals to mv square by r. Here n cos theta equals to mg. For safe turn, n sin theta must be equal to mv square by r. Let us take this is equation 1. And second point is n cos theta, which is equals to mg. Because it is not there is no motion upward direction and downward direction. N cos theta balances the mg and n sin theta balances the centripetal force. Now take 1 by 2, equation 1 by 2, this is case 1. 1 by 2 means n sin theta by n cos theta, which is equals to mv square by r by mg. Here mm gets cancelled, nn gets cancelled, tan theta equals to v square by rg. Now from that, what we can write? Theta equals to tan inverse of v square by rg. Here theta is called as banking angle. Why we are using this theta means for getting safe turn at the circular track. For safe turn. Here second case is n sin theta greater than mv square by r. N sin theta is greater than mv square by r means it slides down inward direction. Now at that time frictional force act upward direction. Free body diagram you can see here again. This is car, inclined plane, this is mv square by r and weight is mg, and this is normal reaction. This is horizontal component of normal reaction, and this vertical component of normal reaction. This is theta, this is theta, this is 90 minus theta, this is theta. So this is n cos theta, this is n sin theta. Now I am dropping this n because I divide into two components. If n sin theta is greater than mv square by r, then it slides down. At that time frictional force act upwards. Frictional force direction is upward. This is theta means. Now this is theta, this is also theta because both are parallel lines here. Theta means what we can write this. And F I am going to resolve into two component. Horizontal component is F cos theta. Along this direction. Vertical component is F sin theta. Okay. Now here see this diagram. Additionally we are adding F cos theta in this direction. And upward direction additionally we are adding F sin theta. For safe turn, all forces must be equal in opposite direction. N sin theta, which is equals to mv square by r plus f cos theta. And move this term this side. N sin theta minus f cos theta, which is equal to mv square by r. Now n sin theta minus, instead of f I am writing mu n cos theta, which is equals to mv square by r. Here f equals to mu n. You know that frictional force is equals to mu into n. N I am taking common, sin theta minus mu into cos theta, which is equals to mv square by r. I am taking this is equation 1. And upward force, downward force must be equal. N cos theta plus f sin theta, which is equals to mg. Here n cos theta, instead of f I am writing mu n sin theta, which is equals to mg, because frictional force equals to mu into n. I am taking n common, sin theta, cos theta plus mu sin theta equals to mg. Let us take this is equation 2. Now divide equation 1 by 2. Now equation 1 upon 2. From that n sin theta, n of sin theta minus mu cos theta by n of cos theta plus n sin theta. Which is equals to mv square by r by mg. Mm gets cancelled, nn gets cancelled. Now rg move that side, you can get V maximum. Here rg of sin theta minus mu cos theta upon cos theta plus mu sin theta, which is equals to V square. V minimum value I am removing square, which is equal to square root of rg of sin theta minus mu cos theta upon cos theta plus mu sin theta. This is the minimum velocity to get the safe turn in circular track. If you decrease the velocity than this minimum velocity, skid downwards or slide downwards, V is less than V minimum. Case 3, another possibility which is skid outwards when it is centripetal force is greater than the inward force, that is n sin theta. There is a tendency to skid outwards. When it skid outward, frictional force act downward. That frictional force is F. That theta means horizontal component F cos theta and vertical component is F sin theta. Take this free body diagram for this car. Simply downward mg plus F sin theta is acting and upward n cos theta is acting and outwards centripetal force mv square by r and inwards F cos theta plus n sin theta is acting. These are the forces acting on the car. Free body diagram. For safe turn, all forces must be equal and opposite. Here what is the maximum velocity? Here n cos theta, which is equal to mg plus F sin theta. Now move this term that side. N cos theta minus F sin theta, which is equal to mg. We know that frictional force F equals to mu n. I am going to substitute this in the equation. N cos theta minus mu n sin theta, which is equal to mg. Here I am taking n common. N of cos theta minus mu sin theta, which is equals to mg. Let us take this is equation 1. And this horizontal forces equated F cos theta plus n sin theta, which is equals to mv square by r. Move this here, F equals to mu n, substitute this value in that, mu n cos theta plus n sin theta, which is equals to mv square by r. I am taking n common. Mu cos theta plus sin theta, which is equals to mv square by r. Let us take this is equation 2. Now divide the equation 2 with 1. N of mu cos theta plus sin theta upon n of cos theta minus mu sin theta, which is equals to here mv square by r by mg. Here mm gets cancelled, nn gets cancelled. Now finally here Rg, move that side, Rg upon Rg into mu cos theta plus sin theta upon cos theta minus mu sin theta, which is equals to v square. If you want to v value maximum velocity, remove square and v maximum equals to square root of Rg mu sin theta plus mu cos theta upon cos theta minus mu sin theta square root. This is the maximum velocity while getting turning on a circular track, banked roads. If velocity is greater than this maximum velocity, it will skid outwards.